today we are going to use triple integral to find the volume of a boundary given. So given the limit from D to A on the x-axis and on D to C on the y-axis and given D to S on the z-axis, we can find the volume of this square of this cube if we know the limits. So by using triple integral, we first put all the limits from A to B on the dx axis and D to C on the dy axis and R to S on the dz axis. And after that, if you want to find the volume, we can ignore this function since we are finding the volume. Triple integral will give us the volume. And then after that, we will just do the mathematical part to find the volume. Now we are going to show you example 1 how to find the volume by using triple.
We are going to look at example. Given that we given example 8y z dx dz dx and dy, you are told to integrate it from 0 to 1, 2 to 3, 0 to 1, and it's a triple integral. So you just integrate one part by one. So you integrate first in respect to x, respect to z, and respect to y. So in this example, we are going to integrate it in respect to z. So when we integrate this function in respect to z, so we integrate the z part, so it becomes 8xy z squared over 2 dx dy. After we integrate it in respect to z, we substitute the values from 0 to 1. So the function now becomes 0 to 1 to 2, 2 to 3, 4xy dx dy. So we integrate it in respect to dx now. So it becomes 4x z squared y over 2. So then after integrating in respect to dx, to substitute the values 2 to 3. So we just remain with 10y dy, which now we are going to integrate for the last time in respect to dy. So when we integrate in respect to dy, we get 10y squared over 2. Then we substitute the values from 1 to 2. So we get 5 times 3, which we get the answer 15.
This is example 2, and when we are given functions, these functions and this function, we can find the plane of this upper side and the plane for the lower side. And if we want to find the volume in between these two planes given the boundaries, we can find the volume by triple integrating. So after that, let's look this plane from y and z axis from the front view. So when here y is equal to 0, we can know that z equals to 4 minus 2x, and same here, z equals to 2 minus x over 2 when y is equal to 0 by substituting the variable into this function. And after that, here we know that since z equals to 0, we can get the function y equals to 2 minus x. Okay, now after that, we have to find the z function. So by using z function, we take 4 over and 2x and 2y. After that, we will get this function. Same to z1, the lower plane. 2 minus x minus y over 2 is the function we get when making x the function. So let's start triple integrating. So when we put in the values, we make dx as the boundary from 0 to 2. After that, by putting dy as the function from 0 to 2 minus x, as you can see here, 0 to 2 minus x with respect to y. And then from 2 minus x minus y over 2 to 4 minus 2x over 2y, we can get from z1 to z2 by putting dz. So after that, we can start integrating. So first of all, we are not putting any functions inside since we need to find the volume, and triple integrals give us the volume. So let's start. First of all, we put in the z since we are integrating with respect to z, and then put in the value. Substitute. By substituting the value, we'll get this function 3 minus 3 over 2x minus 3 over 2y. After that, after putting the function inside, then we again integrate with respect to dy. So same steps. We're making x the constant now, or all other variables constant. We integrate with respect to y, and then you will get this function, and by substituting from 0 to 2 minus x, we will ultimately get this. After that, let's look at here. The final part is integrating it with respect to dx, and by solving it, simplifying it, we will get this, and then we will start integrating with respect to x. And then finally by substituting the value from 0 to 2, the lower limit and the upper limit, we will get this, and then the final, by solving the equation, we will get 2. 2 is the total volume of this between this lower boundary and